All right, so today we're going to be talking about proportional relationships with tables and graphs. So proportions are something we've already worked with, so you should be quite comfortable looking at two fractions set equal to another fraction. And another word that we often use are ratios. So looking at our problem solving and critical thinking, Mrs. Mueller needs to paint two large buckets. The height of each bucket is 32 inches and the radius is 12.5 inches. How much paint does she need to cover both buckets? So when we're talking about buckets, we want to draw at least one picture. We know we have two of them. It has a height of 32 inches. And then it tells us that the radius is 12.5, and I'm going to change that into a decimal. So I'm doing surface area because I want to paint the outside covering of each of the two buckets. So when I do surface area and I'm painting just the outside, I'm talking about the lateral base. So that's just our pi r squared h. We're not actually talking about the area of the top or the bottom of the buckets. So when I do that, I have 3.14. The radius is 12.5. And I'm going to square that radius. So that means I'm going to multiply 12.5 times 12.5. And then the height is 32 inches. So when I do 12.5 times 12.5, I get 156.25. And then I'm going to multiply all that by 32, which is the height. And then I'm going to multiply it by 3.14, which is pi. So the area of one bucket's lateral base is 15,700. But I know I have two buckets. So that's 31,400 inches squared for the surface area of that lateral base. So that's what I would be painting on those buckets. Kind of a review from our prior unit on 3D geometry on the test. So I'm looking at fluency and number work. This is a review on something we've done earlier this week. Write the rule for the following function. So if I'm looking at this, it's like those sequences and patterns. I want to find a rule when I go across the top. And I want to relate that to going across the bottom. So when I do that, I have 2/3 going to 1 1/3. I have 1 1/3 going to 2, and then I have 2 going to 2 2/3. So I know that I'm going upward. So I'm going to be going in a positive direction. And what I like to look at is I like to look at this one where we go from 2 and the whole number to 2 2/3, and I notice immediately that that's plus 2/3. So I like the guess and check. So I'm going to go back to 1 1/3. I'm going to add 2/3 to that. And if I add 2 plus 1, that gives me 3/3. So 3/3 gives me a total of 1 whole, and 1 plus 1 does give me 2. So that checks out. So I'm going to go back over here and I'm going to say, okay, well, is 2/3 plus 2/3 1 1/3? So that gives me 4/3, and that is 1 1/3. So I know that my rule to my function is plus 2/3. All right, moving on to today's lesson. We're going to talk about proportional relationships with tables and graphs. So I'm going to take a look at some vocab first. To identify a proportional relationship with a table, I have to have equivalent ratios going across the table between x and y. The ratio is called, so once I find out I have a ratio, we call that the constant of proportionality. Really big word, and it's also a vocab word on the sideboard. And last, to identify a proportional relationship in a graph, so not a table now a graph, my graph must cross the origin. So we're going to go ahead and look at some tables and graphs and determine are they proportional or not, and then we're going to tell why. That explanation could be in numbers, it could be in words. We just want to make sure that we're using numbers, words, or symbols. So if I look at this table, I need to find an equivalent ratio between x and y. So I'm looking at x and y, and what I like to do is I like to look at these like fractions and set them equal to one another. So I'll use some color to show you that. And how do I determine if fractions are proportional? Well, I can cross multiply. So 2 times 5 is 10. And 1 times 10 is 10. So 10 equals 10. So that's proportional right there. Now, I like to check further. So I'm going to go ahead and I'm going to say, okay, well, let's look at 2/3 and 10/15. Are they proportional? So 10 times 3 is 30. And 2 times 15 is 30 as well, so those are directly proportional. And just for good measure, checking again, 3/4 and 15/20. 3 times 20 is 60, and 4 times 15 is also 60, so this is directly proportional. So how do I explain it? Well, I say proportional or not, so yes, it is. And then my explanation can be 1/2 equals 5/10, my first two proportions. And then I can say, so 10 equals 10 because I cross multiplied to figure that out. And that is good enough explanation for me. So looking at the next slide, in this slide I have a graph. So remember, back up here at the top, graphs must cross the origin. So to determine if the data represents a proportional relationship and explain, so I have proportional or not. So does this graph cross the origin? Well, the origin is right here in the center. So does this graph cross that origin? No, it does not. And you can explain by saying graph does not cross the origin. All right, moving on. I want you to, on the next slide, take a minute, and there's one of each. By yourself, try to determine, is this data proportional or not? So pause the video, and then you're going to come back to it, and I'll go through the answers. So for these first two, I'm going to highlight my fractions and set them. And I'm using the graph. You can move them off to the side if you'd like. So you can do 3/4 equals $6.30 over $8.40. So I like using cross multiplication. So I'm going to take my calculator, or by hand, 630 times 4 gives me 25.2. And then I'm going to do 3 times 840. That gives me 25.2. Now I would make sure I check at least one more. So I'm just going to go down. I'm going to do the next set of numbers. So I'm doing 4/6 equals $8.40 over $12.60. When I do that, and I'm not going to rewrite these, I do 6 times 840. Write that down, 50.4, and 4 times 1260, 50.4. So yes, it is proportional, and I can use that as my explanation. Looking at this graph, I can see that it is making a line. So, and it is going to cross over the origin if I continued the graph. So you're probably thinking, well, is it proportional or not? Well, if I look, it is going to cross over the origin because I'm going to go down. if I look here, I'm going to look at the pattern. So I'm connecting the dots like a stair step. So I go up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, and I'm just doing that by counting as I go up 3 over 1, up 3 over 1, up 3 over 1, and continuing. So if I want to continue that pattern, but I run out of room to go up and I need to know if it crosses the origin, I'm going to actually do it backwards. So I'm going to go over 1, down 3, and if you see, it is going to go across the origin at some point. Sorry, that line's really bad. Let's try that again. Move that over. It is going to cross the origin. So is it proportional? Yes. Crosses the origin. All right, so again, pause the video. Go ahead and do the last two. So you do one of each, the graph and the table. And then come back to this video. So if you look, this one looks a little different because our graph is curvy, but I can directly see that it crosses the origin right here. So that should be pretty easy tell to say proportional or not. Yes, and crosses the origin. Going to the last one, looking at the table, I'm gonna look at those proportions. So I'm gonna cross multiply, working with some negative numbers here. So 2 times negative 8 is negative 16. 4 times negative 4 is negative 16. And I'm going to check at least one more. So I'm going to check this 4, 6, and 8, negative 12. So don't let tables make you think those aren't fractions, because they are. So 6 times negative 8 is negative 48. And 4 times negative 12 is negative 48. So these both check out. So it is proportional. And here is your proof. All right, if you have any other questions, you can try and shoot me an email on those, but you're going to take your quiz next, and then you're going to do your independent practice.